Hi everyone, this is Miss Moriarty, and I'm here to discuss with us topic 7.5 as well as wrap up 7.6. Now, 7.5 is all about indoor air pollutants as well as indoor air quality. Now, it's something that you wouldn't necessarily think about, but being indoors, especially in, say, the Northeast, right, we experience much colder temperatures in the wintertime than, say, some other parts of the country. We tend to spend a lot of our time indoors. And a lot of the pollutants that we've now discussed in our Unit 7 can also collect and accumulate indoors, decreasing the air quality that we find in our homes, schools, and other types of buildings. Now, one of the most common indoor air pollutants that we've already talked about, but we'll focus in this lecture here, is going to be carbon monoxide, or CO. This is an indoor air pollutant that we know is odorless. It also does not have any type of smell. And can be classified as an asphyxiant, meaning that you can actually choke on it. Now, how does carbon monoxide wind up in your home or in other buildings? It can come from your furnace or heating units, especially if you use, say, a gas type furnace. If it's not working properly and that then exhaust is not being released out of your home and then kicks back into the home, is how you wind up with an accumulation of CO. Now, some other indoor air pollutants that we do need to be familiar with are particulates, and we collected a lot of those today in our lab, as well as asbestos, dust, smoke, lead, and all of those other pollutants. Now, these indoor air pollutants typically come from human made sources, but they can come from natural sources as well. For example, typically, we've mentioned before in California, due to climate change, they have been seeing greater frequency of larger forest fires. And what winds up happening is that air gets carried around through communities in the California area. And that then outdoor air can wind up indoors, harming not only the outdoor air quality as well as the indoor. Now, what might indoor air quality look like between developed versus developing nations? We've said in the past, back in Unit 6 as well as in Unit 3, we know that developing nations are going to use things like subsistence fuels, ones that they can find very easily and that tend to be localized in that area. So things like biomass, wood, manure, maybe even charcoal. But when these burn, they don't burn necessarily very clean. And so they're going to release things like carbon monoxide, maybe particulate matter, NOx, and VOCs. We also know that if you're going to use wood as your main fuel source, that can also contribute to deforestation. With greater amounts of deforestation, we tend to see greater erosion, which means an increase in particulate matter in the air. And so, if we combust these things indoors, we tend to see poorer ventilation in those areas, which are going to lead to much higher concentrations. And it's actually estimated or so around 3 billion people globally tend to cook with subsistence fuels, resulting in lots of deaths annually. Now, in developed nations, we use more of the commercial type fuel, so coal, oil, natural gas, hopefully even a little mix of renewables in there. But if you happen to use a fossil fuel, we know that this is typically going to be burned in a ventilated a furnace or a stove of some sorts. But even though we are not using a subsistence fuel and have better ventilation, there are still cases of having worse indoor air quality. So it's important to note that a lot of the major indoor air pollutants in developing nations tend to come from the fuel source that they're going to be using, versus in a developed nation, they actually come from a lot of the products that we use in our homes. So things like adhesives in the furniture, the cleaning supplies that you use, maybe the insulation, and way back when we used lead in the paint, that was also another factor. So, kind of focusing in on asbestos. Asbestos is a long silicate particle. Usually, it was used in insulation, but since it has been linked to other issues like lung cancer and so on, it has been phased out of buildings. But that doesn't mean that it's gone forever. So, unfortunately, if a building is very old, really hasn't been upkept, we tend to find asbestos. Now, it's not necessarily dangerous until that insulation gets disturbed and the particulates wind up into the air. Uh, so, if you happen to come upon asbestos at any point in time, it actually will or should be removed by trained professionals that have the proper equipment that are going to help to prevent any of the asbestos from winding up into your respiratory tract. The next one I said before was carbon monoxide. We know that this one tends to come from the incomplete combustion of really any fuel, right? Not all fuel is going to be combusted due to maybe low oxygen or temperature. We know it's an asphyxiant, meaning it can cause suffocation due to the carbon monoxide binding to your hemoglobin protein in your blood. When it binds to the hemoglobin protein, it then displaces the oxygen that gets transmitted around due to that hemoglobin protein. So, in very high concentrations, this is going to be lethal, especially if the area that you're being exposed to in has very poor ventilation. So, in developed nations, we tend to see this happening in homes that have a malfunctioning natural gas furnace. Now, we can detect this using carbon monoxide detectors. Everybody should have one in their home, similar to a smoke detector. But in developing nations, we can tend to see CO being emitted from maybe indoor biomass combustion, right? Using it to maybe cook something or heat something. And so we don't really have the means of prevention in developing nations as we do maybe in developed. Now, another indoor air pollutant is volatile organic compounds. Now, when we talk about VOCs as being an indoor air pollutant, we tend to talk about how it comes from lots of chemicals. So, the chemicals used in your home, things that might vaporize, enter into the air, has the potential to irritate your eyes, lungs. Um, Usually it comes from adhesives or sealants. So if you're trying to put down a new carpet, that tends to release VOCs. Formaldehyde, which is a common adhesive used in carpet glues, is also considered a VOC. Cleaners, deodorizers like Febreze, plastics, fabrics, all of those release volatile organic compounds. Another one we've mentioned is radon gas. We know this one is something that comes from the natural release or decay of uranium. Usually, if this is going to be found in your home, it tends to be found in greater concentrations near your basement. And the reason for this, it can enter in through cracks in the foundation of your home. It can also wind up in the water supply if it's seeped into the underground water. If exposed to radon for long periods of time, it tends to lead to lung cancer. Now, how might you detect or prevent radon? You can always use radon test kits to pick up on whether or not you have radon present. And if you do, then you may need to maybe seal the cracks in your foundation or maybe increase ventilation in your home. Now, the last one is going to be dust and mold. So, dust and mold are usually natural indoor air pollutants that can worsen symptoms of asthma, bronchitis. We know that dust tends to settle in homes naturally. It's usually disturbed by movement. I know a lot of us in our labs today tried to measure whether or not high traffic areas had greater amounts of dust versus not. Mold is another natural form of indoor air pollutants that tends to develop in very dark or damp areas. Um, Now, mold, most of the time, not as dangerous, but black mold is usually a class of mold that can release spores into the air, can be very harmful to your respiratory system, and must be removed physically by fixing maybe the water or the leak and then ventilating the area. And then the last one is lead. Now, lead can be an air pollutant. It can also be a water pollutant. So, lead's going to come up again in our discussions in Unit 8. Where did we find lead most likely in homes? It was actually found in paint. And it was actually the EPA who banned lead in paint around 1978. Uh, Now, why is lead so bad? And, why do we classify it as indoor? Well, when it was found in the paint, typically the paint chips off of the walls, off of the windows. And what they found is children that were then living in these homes with lead paint either inhaled it as a dust or if the paint chipped, the children would then actually consume the paint. And what this wound up doing was damaging the central nervous systems of these children, and wound up hindering them in their development. We can also find lead not only in the air, but also in pipes, which can be released into your drinking water, but it's a little less common than the lead paint. Now, how do we prevent this from happening? Well, you can remove it from the home by stripping the lead paint, replacing it with non lead based paint, maybe even change your pipes if we find lead in the pipes. At this point, guys, I'd like you to turn to 7.6. We're going to kind of wrap up a little bit on 7.6. Now, we've talked a little bit about these. This was the vapor recovery nozzle, this was the catalytic converter. Remember, these two devices are ones that are put into place to try to prevent things like volatile organic compounds, NOx, CO, and so on. And these are referencing vehicle emissions. We then left off in talking about dry scrubbers versus wet scrubbers. These are types of scrubbers that can be placed upon, say, a coal-fired power plant, for example. What these are going to do is help to then eliminate the SOx, NOx, VOCs, and so on from entering into the atmosphere. Now, two other types of solutions to air pollutants that we need to know is one called an electrostatic precipitator. This is another one that can potentially be found on a power plant or factory. Here, the emissions are going to pass through a device that has negatively charged electrons, giving particles that negative charge. Those then negatively charged particles are going to stick to then the positively charged plates. And what's going to wind up happening is it's going to then attract them and then trap them. The cleaner air is then going to move out of that unit, and the positive collection plates are then, over time, discharged. Those particles will then fall off and will most likely be disposed of in most likely a landfill. Somewhat similar is a baghouse filter. So electrostatic precipitators and baghouse filters are really good at helping to prevent particulate matter. Here, a large fabric bag is then going to filter or trap any of the particulate matter from combustion or from some sort of industrial process. So very, very similar, right? Combustion is then going to exhaust, right? Stream moves through, dust particles are trapped in a series of then filter bags. Those filters move out the cleaner air. The shaker mechanism inside of the device is then activated, dislodges any of those trapped particulates, and then once again, kind of similar to our electrostatic precipitator, those then particulates that were filtered out are collected and then taken to a landfill for disposal. All right, guys, that is it for my video for today. Just remember, we know that the vapor recovery nozzle, catalytic converter are ways in which we can prevent pollutants from vehicle emissions. Things like wet versus dry, baghouse filters, and electrostatic precipitators are all forms of industrial air pollution prevention. All right, everyone, that's it for the video for today. Please make sure as you watch the video, you took notes and mark this as done.